Hello, good evening everyone. Welcome to BYJU'S exam prep. So I hope that the video and audio is absolutely fine. Yes. So I have got that information that I have this video and audio absolutely fine. So guys, today we are in the third session of our EMFT, and in the last 2 days we have finished the two parts and we have solved some fresh questions of the EMFT which you might have never seen before. And now we are going to solve the questions from the EMFT, other rest of the topic like your you can say the wave propagation, like your plane wave, other than the plane wave transmission line questions will also be there, and there will be a questions from your antenna. So these are the topics which were left in the past last two sessions. So I am going to include the sessions on yes, RBHA. Good afternoon. Good afternoon. So let's start the session. And those who are not aware about myself, so this is Saket Verma, and I have done MTech from IIT Guwahati, having more than 13-year experience and having a expertise in the different subjects like your electromagnetic theory and your communication system, advanced communication system, signals and system, etc. So you can join my Telegram group, and this is the link for the Telegram group, and the name of the Telegram group is Electronic by Saket Sir. And here you get the daily dose for the improvement of the concepts, important questions, link of the upcoming session, the PDF notifications. You can clear your doubts, etc. Also in this group, and there is a scholarship test if you suppose want to get the discount in the Gate 24 course or in the Gate 25 course. Suppose you want to prepare for the Gate 24 using our crash course, then also you can opt this particular scholarship test and get the maximum discount in the crash course, as well as if you are preparing for Gate 25, then also this scholarship test will be beneficial for you. So this is the first question, and as usual, I will give you the 3 minutes time to solve the problem. Every problem I will give you 3 minutes time to solve, and once you solve it, you can just mark your answer. Otherwise, I will solve it for you. Yes. So those who have studied the antenna chapter can try to solve this question. This is the question from the topic antenna, and the small dipole of length 0.02 is excited by RMS current of 4 ampere, then the power radiated of the antenna is. I'm giving you 3 minutes time, sufficient time to solve this problem. A small dipole of length 0.02 lambda is excited with the RMS current of 4 ampere. The power radiated by the antenna is 1 minute 40 seconds left. Let's see how you can solve these questions. Yes, so students are still joining. So answer you have got is B, and I will say that this is not the correct answer. Still, you have 1 minute. Check your calculation if you are getting the right answer or not. So I think nobody could solve it. Yeah, the first answer was the wrong. So answer is let's solve. And because this is the small dipole, so it is a Hudson dipole because the length is very very less. So for Hudson dipole, okay, for Hudson dipole antenna, the radiated power you can calculate by the IRMS square into radiation resistance. So for this calculation, you need a radiation resistance. So the radiation resistance you can calculate for Hudson dipole. This is 80 pi square dl upon lambda whole square. So this is 80 into pi square dl. Dl is what? The length. So this is 0.02 lambda divided by lambda whole square. So now it is 80 pi square into zero point zero 0.02 square because the lambda and lambda will get cancelled, and we will get 80 into pi square multiplied with 0.02 whole square. So we are getting 0.315. So we are getting 0.315 ohms. And now if I substitute the value of the current, that is RMS current was already given, and 0.315, so 16 into this is 5.05 watt. So the right answer for this is 5.05 watt. Okay, 5.05 would be the right answer for this question. Now answer this. In order to achieve the maximum unambiguous range of 160 km, what should be the pulse repetition frequency? This is a question from radar actually. Let's see if you can solve or not, because now this is the radar is not the part of syllabus. So this question has come from the ISRO examination point of view. So if you are preparing for ISRO, then at least you should know that how to solve this question, because you have already studied the EMFT and some part of the EMFT was radar. So I hope that you are knowing about this basic terminology related to radar system, and you know about the maximum unambiguous range and the pulse repetition frequency in the radar system. So 1.5 minutes more to solve this problem. Yes, RBHA movies. Hello, you can answer the question. Yes, Agnika, you have got the answer as C. Akansha also came. So you got answer C. So yes. So we know that the radar range equation, that is the ambiguous range, is R is equal to Ct by 2. This is the basic formula because the time delayed in the radar system is the two-way propagation. So if you want to calculate the delay in the radar system, then you have to take the 2R divided by velocity, which is velocity of light. So from here this formula came, and the R is equal to Ct upon 2, where the T is nothing but the inverse of the T is nothing but the frequency. So the maximum unambiguous range is given, which is 160 kilometer, and we want to calculate the frequency. So 3 into 10 to the power 8 into 2 into F. So from here if you calculate, this is F is equal to 1.5 into 10 to the power 8 divided by 160 into 10 to the power 3. So this is coming out to be how much? It should be your C option, na? 10 to the power 8 divided by 160 into 10 to the power 3, 937.5. Yes, exactly, it is coming 937.5 pulse repetition frequency. That means pulse per second. This is your final answer. Option C. Correct. Now answer this one. Within the 3 minutes, you have to solve because I cannot give you more than that. Consider a lossless transmission line with the characteristic impedance Z0. If the line is terminated with the load impedance of 80 ohm, then the minimum input impedance of the line is. If you are from physics, then definitely the electronics would be the better choice for you. Electronics would be a better choice for you. That is easy. You are getting answer as option C, Akanksha. Yes, last 1 minute. Sagnika, if you are there, you can also answer quickly. Yes. So you also got the answer. So the question is the characteristic impedance, minimum input impedance if we want to calculate. So minimum input impedance, that is the input minimum, is nothing but the characteristic impedance divided by standing wave ratio. How do we calculate the standing wave ratio? The standing wave ratio is nothing but the, because the load is resistive, okay, because the load is resistive in nature, the stand, and also greater than that, so this is ZL upon Z naught. So it is nothing but a 80 upon 50. So you can say 8 upon 5. Now we will calculate the input impedance minimum value. which is the characteristic impedance, it is 50 and into 8 upon 5. So it is 250 divided by 8. So it is 8 3 is a 24, 1 and 2 zeros, 2 5. Yes. So 31.25. 31.25 is the right answer for this question. Now you answer this one. Guys, answer this question. A glass fiber has the core diameter 50 micrometer, a core refractive index 1.62, cladding refractive index 1.604. If the light having a wavelength of 1200 nanometer is used, then the acceptance angle is. Akansha, Sagnika, last 40 seconds. Yes. So the right answer for this is option C, because the acceptance angle is theta A is equal to sine inverse root over n1 square minus n2 square, where n1 is a refractive index of core, and n2 is a refractive index of cladding. Okay, so the value is theta A equal to sine inverse root over n1 means 1.62, that is the clothing core refractive index, and then the cladding 1.604. So when you solve this, the answer would be 13.13 degree. So yes, the right answer is option number C. Correct. ERF, let's leave this. Now answer this one. Akansha, is it positive or negative? You are saying 0.6, whether it is a positive or negative. Negative. Yes. So answer is minus 0.6. So we know that the reflection coefficient is given by ZL minus Z naught divided by ZL plus Z naught. So ZL is Z naught upon 4 minus Z naught divided by मैग्नीट्यूड में एन किया. अच्छा, मैग्नीट्यूड क्यों किया है यहाँ पे? क्वेश्चन में आपको नहीं बोला है ना. सो यहाँ से -3 Z0 डिवाइडेड बाय 5 Z0 आ जाएगा. 4 और 4 कैंसिल. Z0 कैंसिल. सो -3/5 -3/5 इज इक्वल टू -0.6. आंसर इज -0.6. चलो इसको सॉल्व करो. Yes, so one answer I have got. So the number of mode is V square by 2. So it is 24 square divided by 2. So it is 12 into 24. 288. Yes, so right answer is 288. Correct. Now answer this. The speed of light in a given medium is measured as 2.1 into 10 to the power 8. The refractive index of the medium is. Refractive index 44. How it is possible? See, the refractive index in any medium is defined as velocity of light in vacuum, okay, and velocity of light in a medium. So velocity of light in vacuum is 3 into 10 to the power 8. Velocity of, sorry, vacuum is 2.1. It is given as 2.1. And velocity of light in a medium, oh, wait, this was 3 and this is 2.1. So 3 divided by 2.1, so you can say 30 divided by 21, it is 1.428. It is 1.428. So this is the refractive index, 1.42. Yes, Akansha, correct. Now answer this. A distortionless line operating at 60 megahertz has the following parameters. The resistance per unit length you want to calculate. The resistance per unit length you want to calculate. What is the answer? 2.5. 2.5. Yes, so 2.5 is the right answer. Let's wait for others to answer. So we, because this is a distortionless line, what is the condition for the distortionless line? The R by L should be equal to G by C. R by L is equal to G by C. So G, L, C, everything is given. Now the operating frequency is always also given. So we can calculate the value of R from L G upon C. The value of L is 2 into 10 to the power minus 6. The value of G is 0.05 and the value of C is 40 into 10 to the power minus 12. So from here if you solve, this is 2 into 10 to the power 2 into 5 into 10 to the power minus 8 divided by 4 into 10 to the power minus 11. So this will get cancelled and we will get 2.5 into 10 to the power 3. So that is nothing but a 2.5 kilo ohm per meter. So answer is 2.5. So guys, if you have not downloaded the BYJU'S exam prep app, so download the app now, because in the app you are going to get the multiple benefits where you can see the leaderboard also. So the link is given in the description to download. Now answer this question. Come on guys, solve this question. See, you are getting? Yes. So both of you are getting C. Yes, C is the right answer. Because here it is asking for end fire array. So for end fire array, beta is equal to, you will take minus xi is equal to this, phi equal to 30, d is equal to lambda by 4. So beta is equal to 2 pi by lambda. Yes. So we will take, because it is asking for the maximum radiation, that is the main beam. So xi is equal to 0. Then alpha plus beta d cos theta equal to 0. We want to calculate the alpha. So it is minus beta d cos theta and minus of 2 pi by lambda. The distance is lambda by 4 and this is the cos 30. So this lambda and lambda will get cancelled. So minus pi by 2 cos 30 and cos 30 is your also root 3 by 2. So root 3 pi by 4. This will be the right answer. Now answer this. Got it? Last 11 seconds. Electric field intensity at a distance of 10 kilometer from an antenna. Anyone got the answer? ये कॉन्सेप्ट याद नहीं है? भूल गए? भूल गए हो? कोई दिक्कत नहीं है, अभी बता देता हूँ। ठीक है, सो राइट आंसर इज 0.189। चलो देखो, डायरेक्टिव गेन का फॉर्मूला लिख लेते हैं पहले, है ना? यहाँ पे लिख, ये नेक्स्ट पेज में बता देता हूँ। देखो डायरेक्टिव गेन का फॉर्मूला, ठीक है, डायरेक्टिव गेन का फॉर्मूला क्या होता है? 4 पाई इंटू रेडिएशन इंटेंसिटी के टर्म्स में यू थीटा कॉमा फाइव डिवाइडेड बाय रेडिएटेड पावर। ठीक है, फिर ये 4 पाई, इसको हम लिख सकते हैं आर स्क्वायर इंटू पी रेडिएटेड, पी एवरेज। ओके, आर स्क्वायर इंटू पी एवरेज डिवाइडेड बाय पी रेडिएटेड। अब यहां से हम लोग और लिख लो तो 4 पाई आर स्क्वायर, और एवरेज पावर को आप लिख सकते हो, बिकॉज इट इज एवरेज पावर, सो ई नॉट स्क्वायर अपॉन 2 ईटा लिख सकते हो, टाइम एवरेज पॉइंटिंग वेक्टर को, है ना? एवरेज पावर डेंसिटी है वो, सो पी रेडिएटेड। अब ये हो जाएगा पूरा आपका डायरेक्टिव गेन, जिसको डिनोट करते हैं जी डी थीटा कॉमा फाइव से। ये हमारा फॉर्मूला निकल के आता है इलेक्ट्रिक फील्ड के टर्म्स में। ठीक है, इंपॉर्टेंट है, इसमें गेट में ऑलरेडी 2 क्वेश्चन आ चुके हैं, तो ये वाला जो आपका फॉर्मूला है बहुत ही इंपॉर्टेंट है। ठीक, अब आ जाते हैं हम लोग क्वेश्चन पे। हमको निकालना क्या था? इलेक्ट्रिक फील्ड इंटेंसिटी निकालना है। तो चलो पहले इलेक्ट्रिक फील्ड इंटेंसिटी के फॉर्म में इसको लिख लेते हैं। तो इलेक्ट्रिक फील्ड इंटेंसिटी के फॉर्म में लिखोगे तो ई नॉट का वैल्यू आ जाएगा जी डी, ठीक है, थीटा कॉमा फाइव, फिर मल्टीप्लाई कर दो रेडिएटेड पावर से, फिर मल्टीप्लाई कर दो 2 टाइम्स ऑफ ईटा से, डिवाइडेड बाय 4 पाई आर स्क्वायर, और फिर ले लो आप सबका रूट, यहाँ पे ही आ जाएगा। ठीक है, अब बस आपको सब्स्टिट्यूट करना है, वैल्यू आपका आंसर आपके पास है जी डी थीटा कॉमा फाइव। ये 3 dB दिया है, डीबी में है, नॉर्मल में कन्वर्ट कर लो तो 10 टू द पावर 0.3। रेडिएटेड पावर कितना है? 30 किलोवाट, सो 30 किलोवाट ले लो, और ईटा कितना होगा? वही 120 पाई, ठीक है, डिवाइडेड बाय 4 पाई, कितने डिस्टेंस पे निकालना है? 10 किलोमीटर पे निकालना है, सो 10 इंटू 10 टू पावर 3 का होल स्क्वायर। सो ई नॉट की वैल्यू कितनी आ जाएगी यहाँ से? 0.189। ठीक है, करेक्ट है? चलो इसको सॉल्व करो। Got the answer? Yes, good afternoon. Answer, you are getting D, option D. Yes, so here we want to calculate the reflection coefficient. So reflection coefficient is gamma is equal to ZL minus Z naught divided by ZL plus Z naught. But because it is given that half wave dipole, so what you have to do? Okay, because it is given as half wave dipole, then what do you have to do? For half wave dipole, the ZL is 73 plus 42.5. Okay, the ZL is 73 73 plus J 42.5, that is fixed for half wave dipole, minus 50 divided by 73 plus J 42.5 plus 50. So after calculating this, you will get your answer. Okay, now the calculation is your, I am leaving it for you because it is just the rationalization you have to perform. Only magnitude is important. Okay, the magnitude is only important term over here. 73 minus 50, you can also calculate it as 23 plus J 42.5 and divided by 123 plus J 42.5. Now magnitude of gamma you can calculate easily, and if I calculate it, suppose 23 square plus 42.5 square divided by 23 square plus it is, yes, 123, actually 123 square plus 42.5, we are getting 0.392, 0.392 we are getting. Okay, now the 0.392 approximately we are getting 0.36, and why we are getting a different value? Actually we should get the same value, 23, just for, okay. Now we have to calculate the standing wave ratio. So standing wave ratio is, it can be the different answer also with 1 plus mod gamma divided by 1 minus mod gamma. So 1 plus 0.392 divided by 1 minus 0.392. It is 2.28. So yes, so we are getting option D. It is 2.28, near about option D we are getting. Parabolic dish antenna you might not be aware with, but still you can solve it this question. But because this is not exactly related to the parabolic reflector antenna. Minimum distance required for the far field representation. What is the concept behind this far field representation? Last 1 minute. A you are getting. See what is the formula for this? The range greater than equal to 2d square upon lambda. Okay. So d is the dimension and 150 meter is given. So this is 150 which is greater than equal to 2 into dimension which is 2.4 square divided by lambda is c upon f. So 3 into 10 to the power 8 divided by f. So you are getting the frequency less than equal to 150 into 3 into 10 to the power 8 divided by 2 into 2.4 ka whole square. So f is less than equal to 150 into 3 into 10 to the power 8 divided by 2 into 2.4 square. So from here you are getting 3.9. So 3.9 gigahertz. Okay. Now answer this. The input impedance at the source and you want to calculate. This system is given. The two identical antennas, each of input impedance of 100, are fed by the 50 ohm transmission line. The input impedance at the source and we want to calculate. Okay. Answer this question. This is very popular type of question. Generally, this type of questions you might have seen before also. This is Z in 1. Okay, that is Z in 1. Suppose you are looking at this end with the input impedance Z in 1. When you are looking at this end, then you are getting Z in 2 double dash. Yes, Akansha, you have got the right answer. Be confident on that. So Z in dash, because it is a lambda by 4 length transmission line. So Z naught square upon ZL, everything is 50 ohm divided by ZL. So it is 25. So for this also it is 25. So the parallel combination is 12.5. Okay. Let us say Z in input, Z in, this is Z in, this is also Z in, yes, let's say Z in 1 in parallel with Z in 2. Okay. Now this will become the load. So it will become the load. So this is the load. Now the Z in is Z naught square, which is 50 whole square divided by 12.5. So it is 2500 divided by 12.5. So it is 125 into 2, so 200. Yes. So 200 ohm is the right answer for this question. Okay, Akansha. So how is your preparation going on, Akansha? Can you tell me? Because what are the subjects you have learned already? So guys, this is it from my side today. And thank you for watching this session. And you can solve more questions on this. I have already, yes, EDC और EMT रहता है. अभी बचा है. Okay, EDC और EMT रह गया है अभी. ठीक है, तो ये मेरे साइड से गेट 24 के क्रैश कोर्स के लिए रिगार्डिंग इन्फॉर्मेशन है. यू कैन ज्वाइन दिस क्रैश कोर्स बाय कॉलिंग इन टू दिस नंबर. यू विल गेट एन डिटेल अबाउट दिस कोर्स. एंड फॉर इलेक्ट्रिक मॉक में 50-55 आ रहा है. ठीक है आकांक्षा, कवर हो जाएगा. ठीक है, अभी अच्छा नंबर है आपका, 50-55 आ रहा है. इसको इम्प्रूव कर लो, 70-75 तक आ जाना चाहिए दिसंबर तक. और फिर जनवरी तक उसको 80 क्रॉस करो, है ना. मुझे लगता है कि आप कर सकते हो, क्योंकि जैसा मैं आपके और भी दूसरे सेशंस में भी मैं आपको देखा हूँ, तो आप आंसर तो अच्छा करते हो, तो आप कर सकते हो. क्रैश कोर्स का प्राइस आकांक्षा इसी नंबर पे कॉल करके थोड़ा डिटेल ले लो, है ना. इस नंबर पे आपको डिस्काउंट वगैरह सब मिल जाएगा, क्योंकि क्रैश कोर्स है और आपके जो जो दो सब्जेक्ट बचे हैं उसके लिए आप कर लो. तो इसमें आपको ना काफी हद तक डिस्काउंट मिल जाएगा, 70-80% तक मिल जाएगा. और नहीं तो अगर सपोज डिस्काउंट नहीं मिलता है, तो आप संडे यानी कि कल एक स्कॉलरशिप टेस्ट होगा आपका, क्योंकि वैसे भी सब्जेक्ट्स में कमांड अच्छा है, तो आप स्कॉलरशिप टेस्ट दे दो. और उसमें आपका जो भी स्कोर आएगा, आपको उसके बेसिस पे स्कॉलरशिप ऑफर हो जाएगा. तो आप उसके बाद फिर इस क्रैश कोर्स में ज्वाइन कर सकते हो. ठीक है, तो वो एक बार आप चेक कर लो, है ना. मिनिमम फीस दे के ही आप आना, क्योंकि अब टाइम लिमिटेड है. तो आपका 4-5 thousand 10,000 तक हो जाता है, और आपके दो सब्जेक्ट्स अगर रेडी हो जाते हैं तो बहुत अच्छी बात है. ठीक है, थैंक यू. फिर मेरा जो नेक्स्ट सेशन है ना, वो प्रीवियस ईयर क्वेश्चंस ऑफ कम्युनिकेशन पे भी होगा. और इसके बाद फिर मेरा एक और सेशन होगा सिग्नल्स एंड सिस्टम के ऊपर, मैराथन, जिसमें मैं आपको थ्योरी कराऊंगा और रिवीजन करवाऊंगा. और उसके बाद एक ईएमएफटी के फिर से क्वेश्चन सीरीज होंगे. तो अभी नेक्स्ट मंथ जो है ना, अक्टूबर में थोड़ा इंपॉर्टेंट रहेगा आकांक्षा. तो आप टेलीग्राम ग्रुप में हो ना, तो अगर टेलीग्राम ग्रुप में हो तो आप, अगर नहीं हो तो लिंक में स्टार्टिंग में जो दिया था उसमें ज्वाइन कर लेना, है ना. ये वाला जो टेलीग्राम ग्रुप का लिंक है, इस ग्रुप में ज्वाइन कर लो. तो मैं ना उसमें अपने क्लास के लिंक शेयर करता हूँ, क्योंकि पूरा अक्टूबर मंथ मैं डेडिकेटेड क्वेश्चन सीरीज कराने वाला हूँ, ऐप में भी और हमारे यूट्यूब में भी. तो बहुत सारे क्वेश्चन सीरीज आएंगे, इसी तरीके से आप प्रैक्टिस करते रहो. और होप कि आपका बहुत अच्छा तैयारी हो जाए विद द बायजूस एग्जाम प्रेप. दिस इज टेलीग्राम ग्रुप, यू कैन ज्वाइन. Thank you for watching this, and don't forget to download the BYJU'S Exam Prep app. Link is given in the description. A contact number I have shared you. If you have any query regarding your course of Gate 24 and Gate 25, then you can call in that number and get the detail. And calling number जो है वो description में भी आपका mention है. Thank you.